Tableau will make use of a exponential series algorithm to compute the trends. So in the exponential model, Tableau will make use of the exponential exponential series of algorithm um, to um, to make to compute the trends. So we'll see what exponential series logarithm is. So exponential model will add the trend lines for the growth as well as for the delay. Okay, so using this exponential model, we can add the trend lines for both growth as well as for delay. So in this model, Tableau will make use of the exponential series logarithm to compute the trend of this line. Okay, um, so there are growth and um, as well as delay expressions uh, in case of this exponential model. So the delay expression is y equal to ce to the power of kt. So uh, this is the c y equal to ce to the power of kt is the delay expression. So whereas for growth, it is base e into y equal to ce to the power of kt. So these are the underlying formula for this exponential trendline model. So we need to remember that these are the expressions which are used in exponential trendline. So both growth and as well as the delay are calculated in this exponential model. So there is a one more type of a model type called polynomial. So in the polynomial, Tableau will make use of the polynomial expression to compute the trends. So the expression in the polynomial model is so for exponential model, base e into y equal to ce to the power of kt. Ce to the power of kt. So this is the expression, and for base, this is for base e. For base 10 also we can write a similar formula. And for delay expression within this is y equal to c to the power of kt. In base 10 also y equal to n to the power of kt. Okay, so these are the expressions used in the backend for exponential model. For exponential model, while calculating the trend line. So whereas uh, for polynomial, the expression is for polynomial model, the expression is y equal to b naught plus b1x plus b2x square b2x square plus b3x cube b3x cube and so on. So the polynomials can be n. So we can write any number of number in n. So that is upon your choice. So you can define n here. So bn of x to the power of n. X to the power of n. So where n is nothing but degrees. Here n is degrees. Here n is number of degrees. Okay. So here, so n is this degrees. So we can define n here. So we can change this n. We can change this n. So we can define 2 to 8 here. We can define degrees here. Okay. So the expression used to calculate this polynomial model is this: y equal to b0 plus b1x plus b2x square plus b3x cube, so on, bn x to the power of n. So where n is decrease. Okay. So we can choose any of these model, and there is also power here. Okay. So power is also a new type of a trend model, which is latestly available from 10.5. Okay. So these are the 5 types of trend lines with 5 models. Okay. So for linear um, and logarithmic and exponential, Tableau always takes degree as 2. So the default degree for linear, logarithmic and exponential, Tableau always takes degree as 2. So 2 is the degree for linear, logarithmic and exponential. While computing the trend lines in Tableau, on both the ends we need to take either date field or number field. Okay, so here um, either we have to take the date fields or number fields while computing the trend lines. So whenever we want to compute a trend line on Tableau, on both the ends we have to take either a date field or a new number field. Here we have taken order date field and also a profit number field. So to compute a trend line on both the ends, we need to take either a date field or a number field. If you have only a textual dimension on the view, and if you want to add a trend line, it is not possible. Okay. So if you want to add a trend line on a textual dimension, only a textual dimension, if you only have a textual dimension on the view, it is not possible to add a trend line. Okay. So you need to have a order or a date field or a profit or a number field. So here in this example, we have displayed year-wise profit and added a linear trend line. Okay, so this is a year-wise profit, and we have added a, so here this is a linear trend line like this. So these are the year-wise profits and we are showing a linear trend line which is growing year on year. Okay, so we have used order date in columns and profit in rows. Order date is a date field and profit is a numerical field, and we have shown a trend line. We have shown a trend line by selecting these fields. So when we added a trend line, Tableau automatically created a linear trend model. So when we have added a trend line, so so when we added a trend line like this, so first I'll undo all these things to first add a trend line. So right, so yeah, before, so till here we don't have a trend line. So I have right clicked on the view and then clicked on show trend line and show trend line. So by adding a trend line, Tableau automatically creates a linear trend model. So this is a default trend model, so which is a linear 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 trend line, linear trend line. So so to show the trend model, we have to right click on the view and select the describe trend model. So so if you want to see the trend model, we have to right click on the view and then right click on the trend line, and we have to select the describe trend model. We have to click on describe trend model. Okay, so this will show you the complete description of the trend model. Okay, so this is a trend line model. So it is describing all the values. So for the trend model to be significant, we need to check the p-value here. So if the p-value is less than 0.05, then the model is significant. If it is not less than 0.05, so now p-value is less than 0.05. If it is not less than 0.05, then it is not significant. So we should not use that model. Okay, so if the p-value is only less than 0.05, it is significant trend model. So then we can use it. So if the p-value is more than 0.05, then the trend model is not significant. So the trend is not reliable in nature. So if at all the p-value of a trend model is more than 0.05, then the trend model is not significant in nature. So the trend is not reliable if it is more than 0.0, if the p-value of the trend model is more than 0.05. Okay, so so this is the p-value for linear trend model. So out of the 4 models or 5 models, we have to always take the trend model having the least p-value. So we need to change the trend models and then keep on checking. So now for linear it is 0.03. So to be exact, we will see the trend model again. So here for linear trend model, it is 0.0314. 0.0314. So we'll change the model. Edit, we'll go to edit trend line and click on logarithm. Now we will see the p-value. We'll again go to describe trend model. So it doesn't change much. 0.0314. So we'll again change the trend model. Now we'll see the p-value again. So it has changed to 0.008. So this is a better p-value. So out of the 4 model, we have to take the trend model having the least p-value. So out of 3 trend models that we have checked till now, the least p-value is having for um, for exponent for logarithmic. So 0.008. Okay, so sorry, for exponential. So for exponential, we are having the least p-value till now. So we'll also see polynomial. So this is not even significant in nature. Polynomial is not even significant because the p-value is more than 0.05. So it is not reliable. So again, we'll change the degrees and see that again. So from 2, we'll change it to 3. Again, we'll check this p-value. P-value is not available. So you cannot rely on this. Similarly, you keep on changing the degrees for two steps at least, and then see that. So p-value. So we are not getting reliable p-value. So we will not use this model at all. So we'll check power also. So this is also having a better p-value, not 82375. 8 not 82375, and we'll also see value 82375. We'll check again exponential how much it is. 82375. So exponential model is having the least value. So power is having 8 not 82375. It is this exponential model is having not 82164. So this is the model which is having the least p-value. So what is the model that we'll be considering for this trend line? So what is the model that we'll be considering for this trend line? Are you able to hear me?
Yeah, Kranti.
So what is the model that we'll be considering for this trend line? Which is a model which is having the least p-value?
Exponential one.
Exponential, yeah. So we'll use an exponential model for this trend line. So this trend line shows the exact picture of the data. Okay, so this is the trend of the data. So starting from here and then moving towards starting from 2010 and moves to 2003. So this is the trend of the data. So exponentially it is going like this. So because it's having the least p-value of not 8 213, so you will be considering this trend line. Okay, so this is the exact trend of the data. This is the exact trend of the data. Okay, so this is how we can use the trend lines to show the uh, uh, direction towards which the data is drifting towards. Okay, so similarly we can perform different tasks for each department also we can show a trend line. Okay, by um, just adding one more dimension to the view like this. So for each department we can also show a trend line like this. Okay, so we can also add a trend line from analysis. So from analysis you can add trend line and show trend line. So one way to add a trend line is to right click on the view and then show trend line and then click on show trend lines. So other way is go to analysis tab and then click on trend lines and click on show trend lines. This will add a new trend line to the view. Okay, so these are the two options to show the trends. Right, so from Tableau 9, it is possible to add trend lines directly using analytics pane. So from Tableau 9 version, we will be able to directly add trend lines to the view from analysis pane. Okay, so from even from analytics also, we can write add a trend line. Okay, so from directly going to analytics pane also, you can add a trend line to the view. Add a trend line to the view like this. Okay, so in the last class we have seen forecasting. So using forecasting, we are estimating the future values based on the current and past data. So using forecasting, what are we doing? We are estimating the future values based on the current and the past data. So whereas using trend lines, here, so what are we doing? We are computing the trends on the current and past data. Okay, so we are just computing the trends on the current data, and the current data is the current year. So the past data is the previous years here in this example. So we are computing the trends on the current and the past data. Whereas in forecasting, we are estimating the future values. So in forecasting, we'll be adding one more aspect layer to the data, which is we'll be estimating the future values based on the current and the past data. So in trend lines, we'll just compute the current business trends and also the based on the current and the past data. Okay, so we'll just use a trend on the existing data in trend lines. So forecasting is basically giving us the output as future values, whereas trend lines are giving us the output on the current and the past data. That's the only difference. So also trend lines will execute at the Tableau level. We have to remember that trend lines always execute at the Tableau level. Okay, so these are the trend lines that we use in Tableau. Okay, so any questions?
No, I'm good, Kant.
Yeah, so yeah, if you don't have any questions, so we'll move on to the next topic, so which is regular expressions. So while using calculated fields, so we have seen that there are regular expressions. Okay, um, so we'll see where we can use this regular expressions in Tableau. So the regular expressions is a computer science theory, so which contains sequence of symbols and characters. So these regular expressions will contain sequence of symbols and characters for expressing or describing a string or pattern to be searched from or within the longer piece of text. So if you want to uh, um, search a string or a pattern from a longer piece of a text, okay, if there is a long piece of a text, and if you want to search a pattern or or if you want to describe a string, then you will be using the regular expression. Using the regular expression. Okay, so if it is very useful to extract a required string um, from any product description or from any dimension value, or you can also use that to describe or extract any value from a string. Okay, string from any website name, URL, address, or any product description. Okay, or an item also. If within an item, if you want to extract a string, you can use regular expression um, in calculated field to extract that value. Okay, so regular expressions with its sequence of characters performs string search. Okay, so we can use a sequence of characters like this. So we'll describe each one. We'll see what each does in detail. So with this regular expressions with its sequence of characters like these, A to Z slash S slash D plus. So these are the different sequence of characters. So with these sequence of characters, so it performs a string search. So using these sequence of characters, we can perform the string search or a text search. This is you can perform the string search or text search or pattern matching from unstructured data. Okay, so we can using this sequence of characters, we can perform string search, text search, or pattern matching from the unstructured data or even from the structured data. Okay, um, so we'll see what are the different expressions, regular expressions, basics before moving forward. So here we are discussing about regular expressions. Regular expressions. So this is a computer science theory. So which actually contains sequence of symbols. Sequence of symbols and characters for describing a pattern to be searched from a longer text. Okay, right. So here if we use /s, so all these are used as part of the regular expressions in calculated field. If you use /s, that means this is used for space. Okay, this is used for space. So if you use /w, this is used for any alphanumeric character. Any alphanumeric character. Okay, so this is for any alphanumeric character. So if you use /d, so this is for any digit from 0 to 9. Okay, so any digit from 0 to 9. 0 to 9. Okay, if you use dot, so you can use this is for any special character like slash, comma, colon, etc. Okay, this is for any special character. Special character. Example, slash, comma, colon, etc. Okay, for all these you can use dot. So if you use slash dot, then it is for line end. This is for line end. Okay, so this is for line end and dot. So these are the some regular expression basics. So these are the some so within this, so we have a set of separate expressions for repetitions. For repetitions, if you use plus, so that means if you can use that for one or more repetitions, one or more repetitions. So when there are one or more repetitions, we can use plus. So You can use star when there are zero or more repetitions of a word in the search. Zero or more. So if there are zero or more repetitions, you can use star. Of course, if you are searching for a string, if there are one or more repetitions, you can use plus. If there is zero or more repetitions, you can use star. Similarly, you can use question mark. If there are zero or one repetitions. of a of a of a text, right? Okay, so we can also specify a range. So when we use this symbol, so this indicates a range, the range of characters. Okay, so these are different expressions used for the repetitions of the search string. Okay, so in regular expressions, you have to note that if you want to extract anything, then that pattern must be specified with the help of the characters. So if you in any calculated field, before writing a calculation, so within so if you are using regular expression, calculated in calculated field like this, so we have to in make use of this pattern. Okay, so we have to specify the pattern with the help of characters. So these are the characters which which we should use to define the pattern. So we have to first specify the pattern in the regular expression to extract any word from the longer text. Okay, using these expressions. So for repetitions we can use these expressions. So these are the common expressions, basic expressions that we will use. Oh, so what is a pattern? So a sequence of characters is known as the pattern. So if you define a sequence of these characters, okay, so the sequence of characters is known as a pattern. Okay, so in regular expressions, if we take anything inside the brackets, then it will return that string as an output. So okay, if we take anything between these brackets, okay, so in regular expressions, if we take anything inside the brackets, then it will return the that string. So whatever string that is there within the brackets in the search string defined in regular expression, so that will be returned as an output. That will be returned as an output. So in regular expression pattern, we should always need to specify either in brackets or in square brackets while working with range. So if you are working with range like this, so from A to Z, we have defined that in either a square bracket or a normal brackets. So we have to always um, use normal brackets or a square brackets when we are defining a range. Okay, so when we are defining a range, we have to, so for example, if we are defining a range, we have from A to, if it is from A to A to A to Z. So this is the range. So we have to either define the range like this, or we have to define the range like this, A to Z. Okay, so this is the range. So we have to define using square brackets or normal brackets. So regular expressions is always a case sensitive in nature. So regular expressions are case sensitive. You have to remember that. So if we take any pattern inside the square brackets like this, then Tableau performs the search by taking each and every element of the pattern and stops after the first match is occurring. Okay, so whenever you write anything in between the brackets, so within the brackets, if you write anything between the brackets, so if for example, if you are writing uh, like tab, okay, so if you are writing tab, okay, string, so this is the string, okay, within the quotes. Okay, so if you are writing anything between a tab like this, okay, so um, or you define the tab, okay, if you are writing anything in between the square brackets like this, so um, Tableau performs a search by taking each and every element of the pattern and stops after the first matching is occurring. Okay, so we'll first define, if you are searching for any word, so it will first search for the for first occurrence of the text. So if the match occurs for the first time, so it stops. To perform searching for all the elements or characters of the same character of the same string, we need to use repetitions like plus, star, or a question mark like this. So if you want to perform searching for all the elements or characters, we need to use plus, multiplication, question mark, characters to perform the repetitions. Okay, so repetitions are mainly used within the square brackets. Okay, we also have to remember here that if we are using power symbol, so it searches the patterns from beginning of the string. It searches the pattern from beginning of the string. So if we use a dollar, so it searches the pattern from the end of the string. We'll use an example to actually understand this practically. It searches the pattern from the end of the ending of the string. So if there is a long string and if you are searching for a string, so if you use a dollar, so it will search from the end of the string. Okay, so there is also an operator like this, so it indicates or operator. So it indicates or operator. Okay, right. So now we will actually try to see a task with an example. So before that, so we will first see different types of regular expressions in Tableau. Okay, so here we can see there are four types of regular expressions. So we have four different regular expression functions available in Tableau. So one is regex extract. Regex extract. So what does it do? So the regex extract has a also So this the syntax of regex extract is regex extract of expression and pattern, or a string or pattern. So this is the syntax. Regex extract um, expression or string comma pattern. So it is going to extract the required pattern from the input expression. So okay, it is going to um, extract the required pattern from the input expression. So input expression can be any string. So you can define, you can give any string here. So you can give the customer name in the string. So string can also be an expression here. Okay, so it is going to extract the required pattern from the input expression. Input expression can be any string. You can give the customer name in here. And also if the pattern is not available, it will return nulls. So after the string is given, you can define the pattern, um, like like searching any string, um, from starting with you can use okay, in the pattern you can use this power symbol. So it searches for the pattern from the beginning of the string. So if you use /w, so in customer name uh, it will check for only alphanumeric characters. So if you use plus, so it will check for all the uh, different duplicates or repetitions of the element characters. So we also have to note here that if you use um, if you want to take any pattern inside the brackets, then Tableau performs by searching, by taking each and every element of the pattern and stops after the first matching occurrence. To perform searching for all the elements of character, we have to use the repetition operators like plus or um, star, okay, or star, or so these are um, used to perform the searching for all the elements or characters. So to perform searching for all the elements or characters, not just the first uh, uh, first word, first occurrence, not just the first occurrence. To perform for repeating cases, for searching all the repeating elements, we have to use these operators. Okay, so you can use such operators in the pattern. In the pattern, uh, the pattern, this pattern to search the text. Okay, so um, search the text. So for example, um, in regular expression, we'll take for string, we'll take customer name. Okay, and in pattern, what we'll do is within brackets, within quotes, we'll first define within brackets we'll define starting with. So we'll use power. So using power, you'll only get starting with uh, an a name. uh, okay, um, and then we'll use a square bracket and /w. So what does power do? Power, it searches the pattern from beginning of the string only. What does w/w do? So it actually shows it searches for any alphanumeric character. So if you are performing a range, so we'll be defining in you are defining a range, you will be using square brackets. So in square brackets will be um, searching for um, searching for any alphanumeric character like this, and you'll use these repetition operators if you want to search for one or more repetitions. So we'll use plus here. We'll use plus here. Okay. So this is one example where um, we use the first name. We extract the first name from customer name. So why we can extract how we can extract a first name from this customer name, because we are using the operator called power. So what does it do? So it will search for the pattern from the beginning of the string, and it will search for what? So it will search for any alphanumeric character using /w, and also uh, it will also search for number of repetitions also, so one or more repetitions. So if we click on this, so we'll name this as first name. Okay, we'll name this as first name. Okay, and use that in the row, and we'll also use customer name. Okay, yeah, we have to actually close this. Yeah, so using this regular expression, what are we doing? We are extracting the first name of each customer like this. Okay, as you can see, we are able to extract the first name of each customer. So this is the actual full customer name, and this is the first name of the customer. Okay, so using regular expression extract, we are able to extract the first name. So till now we have discussed that. So using a regular expression, so we can extract a pattern or a search for a string from within a longer piece of text. So using one of the regular expression types, so called regular expression extract, we are actually using a string or a expression called customer name, and within that we are defining some operators here. Okay, so we are defining an operator for using the operators for defining the pattern. So what is the pattern? So first we want the first alphanumeric character, and we want the repetitions of the character. So we have defined using these symbols and extracted the required output like this using this pattern from the expression called customer name. Okay, so this is one of the expression types. So we have four different expression types, regular expression types. So this is regex extract. Um, so we can extract the required pattern from the input expression using regex extract. So there is regex extract nth also. Okay, so there is regex extract nth. So the so what is the syntax of regex extract nth? It is expression or a string, comma, pattern, comma, nth position or index, nth position or index. So it extracts the nth position of the required pattern from the input expression. So you can give an input expression here, and we can extract the nth position. You can extract the nth position. If there is the three words, if you use three, so you can extract the third word from the long word. Okay, so if it extracts the nth position of the required pattern from the input expression. Input expression can be any string here. So if the pattern is not available, it will return null. So if there is no pattern or a third position, so the output will be null. If there is any word or the text in the third position, so it will return that particular text. Okay, so that is the purpose of the uh, regex nth. So we also have regex match. Okay, regex match. So the syntax is regex match within brackets expression or a string comma pattern. Okay, so it is a boolean expression. So regex match is a boolean expression. That means if pattern is exactly matching with the input expression, then it returns true, else it will return false. Okay, so it will check for the pattern. So if it is exactly matching, so then the pattern is exactly matching with the input expression, then it will if the pattern is exactly matching with the input expression, which is a string here, so then it will return true or it will return false here. Similarly, we have reg regular expression replace. Okay, the syntax is regular expression expression or string comma search pattern or a pattern and replacement pattern or replacement. So string comma pattern comma replacement. So it will basically replace the search pattern from the input pattern. Okay, it will replace the search pattern from the input expression if it is existing in the input string. If the pattern is not available, then it will return the input expression as it is. So um, using this expression, what it does is, so it will replace the search pattern from the input expression. So it will we have to define a string and also a pattern, and we also have to define a replacement pattern. So it will replace the search pattern. Okay, it will replace the search pattern from the input expression if it is existing in the input expression. So if the pattern is not available, it will return the input expression as it is. Okay, so um, we'll perform few more tasks to understand these expressions. So here in the regular expression extract, we have extracted the first name. So how can we extract the middle name? So to extract a middle name, so we have to first uh, remove this symbol power. So this will give you all the alphanumeric characters. In brackets w plus. Right, we'll name this as mid name. say we want a last name here. So here, so what is the expression that we are using for last? Uh, we are using this dollar symbol. It searches for the pattern from the ending of the string. So here, what we can do is we can use plus dollar to search from the ending of this text. So regex extract customer name w/w within brackets square brackets plus dollar. Okay. So here, using this type of an expression, we will be able to extract the last name like this. So this is the complete customer name. So using dollar operator, we are and also /w within square brackets, we are able to define a pattern and then extract the last name like this, because using dollar will be Tableau searches for the pattern from the ending of the string. Okay, so using w /w also, it will search for the any search for all the any alphanumeric character. So using that expression, so this is the expression that this is a pattern, this is the expression, and we have defined the string or expression, and also this is a pattern that we are used to extract the last name. So using different operators, we can also uh, we can also extract different strings uh, from the bigger string. So we'll perform one more task to extract item number. So in this task, we'll be extracting item number from item field in Superstore. So this is the item. Okay. So this is the item. For each item, we have item number. So we want to extract item number from item field in the Superstore data. So we want to extract the item number. Okay, here. So we'll create a calculated field. Name it as item number. So we'll use regular expression extract string is item, string is item, comma, in quotes, we'll define, we'll give brackets, and within that we'll define square brackets and use /d. So /d can be used to give any digit from 0 to 9. /d is for using any digit from 0 to 9. Okay, and we'll be using multiply operator. So what does this do? So multiply operator will see for 0 or more repetitions, then we'll be using dot /d. This is slash d. The calculation is valid. We'll click on OK. So this will give you the item number like this. So we want to extract the item number like this. So in those cases, so we'll be using the um, pattern like this. So the pattern that we will be using is to extract the item number from item. So um, we'll be using slash d, so which is any numeric value and the repetition of that also. Or it can be 0 or 1 into dot. It can also be a dot and also slash d, again a numeric value, and then it can be a repetition. So this will extract the item number from the uh, item text like this. So using regular expressions, we can extract the data from the long text like this. Okay. So these are the some of the uses that uh, we can make use of using regular expressions. So
Kranti, I have one question.
yeah.
So while you're scrolling down, I can see characters also, item number. So is that possible?
Yeah, so in those cases, I mean, we don't have any item number for them. So that by default we are getting the first character because we don't
First
have
character. Okay.
any item number for them. But for those which are having an item number, so that also depends upon the item number. So the input text that you are giving. So if the data is clean, you will be getting the exact results. Okay.
Mm-hmm.
Right. So if that for all these items which are having the clean data, you'll be getting the item numbers like this.
Okay.
Okay. So this is just one of the examples that you have given. So mostly we'll be using real-time scenarios like this. So where we want to extract first name or a last name from the text, like customer name, where you can use regular expressions to do that. Okay. Right. So this is about regular expressions. So we'll discuss about geographical mapping or advanced mapping techniques in Tableau. So we'll take a quick break, a couple of minutes, and then come back again. Then we'll look into um, the advanced mapping topics. Advanced mapping topics. Okay. See you after a couple of minutes. Hope you're back. Right. So here, in this section, so we are going to look at geographic analysis. So in Tableau, we can do geographic analysis using all the geo fields. So all the geo fields are indicated with a globe symbol like this. So geo means location. Geo means location. Are you in, guys?
Yeah, Kanta, I'm on.
Right. So geo means location. So if we indicate the locations geographically in the form of a map, then such kind of an analysis is known as geographic analysis. So if we indicate uh, the analysis in the form of a map like this, so if you indicate the locations geographically in the form of a map like this, so then such type of this kind of an analysis is known as geographic analysis. Geographic analysis. Okay. So if you indicate the analysis like this on the form of a map with different sizes of cells on each country, then such type of an analysis is known as geographic analysis. To plot any map, we need latitude and longitude fields for the required locations. So to plot any map, so we need latitude and longitude fields. Okay, so these latitude and longitude fields to generate this type of a map analysis. Okay, for locations. So Tableau automatically generates the latitude and longitude for the default geographic role fields. For the default geographic role fields, So Tableau automatically generates the latitude and longitude fields like this. So what I've done, I've simply clicked on the country region, and Tableau has automatically generated the latitude and longitude fields for the default locations. For US, the default longitude and latitude fields are generated. Similarly, for different countries, it, the latitude and lat long fields are auto generated here. Okay. So if the field is not having the default geographical role, then we need to obtain the latitude and longitude manually using custom geocoding. So there is a concept called custom geocoding, where if a field is not having any default geographical role, then we need to obtain the lat long manually. So using what? Using custom geocoding. We will discuss about that custom geocoding later. So in today or tomorrow's class. So where we'll see how we can use custom geocoding. So this is done because Tableau cannot auto generate these fields for fields which doesn't have default geographical role. So for some fields which are not having default geographical role, Tableau cannot auto generate those fields. Okay, in those cases we can use custom geocoding to define a geographical role to obtain the lat and long for them manually. Okay, so I'm saying default geographical roles. So what are the default geographical roles that Tableau can identify automatically? Okay, so these are the default geographical roles. So these are the built-in geocoding which are by default in Tableau. So this is the geographical role and this is the description. So for area code, CBSA or MSA or congressional districts, okay, or city. So these three are for US only: area code, CBSA or MSA code, and congressional district. So these are specified to um, and also county. So these are specified to US only. So Tableau can automatically detect the lat long for these codes and then generate the map automatically. So um, if you have area codes, example 206.650.415, Tableau automatically generates lat long for this. Similarly, uh, uh, for Dallas Fort, if the text is like Dallas Fort, what Arlington, or TX for Texas. So even if the geofield has these items in it or the members in it, it can identify and generate the lat long. Similarly, for these congressional districts also, for district 3, 4th, 1st district also, all for all these text values, Tableau can generate lat long. Similarly for Clark, Oneida, and such counties. Okay, so for all the other geographical roles like city, countries, okay, and country, region, states or province or zip codes, these are for US and also international. So for different international locations also, Tableau can automatically detect and generate lat long by default. Okay, for example, for Bordeaux in France or Seattle in US, so Tableau can automatically generate lat long for these city names. Similarly, for state or province, it can identify all these different states, like uh, um, or a short form of it, or a full name also can be identified. Also the zip codes of different countries, and also the country name also, or the acronym of the country also can be identified and then given a auto lat long. So these are the different uh, geographical roles that Tableau can identify automatically, right? um, okay, so we'll go back to the Tableau. Yeah. So in Tableau, we are having two types of maps. So if you come to map types in Tableau, we are having two types of maps. One is symbol maps and other one is field maps. So even if you go to show me, we have two types of maps. What that is symbol maps. The other one is field maps. So this is the current one which we are seeing is symbol maps. So the second type of a map is field map like this. So these are the two types of maps that are available in Tableau. Okay, so going back to symbol map. Okay, so if we indicate each and every geographical location with a symbol like circle or square on the map, then it is known as a symbol map. So here we are indicating each and every geographical location with the size and also a shape of a circle. Okay, so circle is the automatic shape that we are using here. Okay, so if we indicate each and every geographical location, so here the geographical location is country. So if we are indicating every country with a symbol like circle, so we are indicating with a filled circle, okay, on the map, then that's why we call it as a symbol map. So coming back to shape filled map, so if we indicate each and every geographical location with a filled portion, then it's known as a field map. So we indicate each and every country. Here the geographical field is country. That's why we are filling each country with a filled portion like this. So if we indicate that, this is known as a field map. Right. So these are two types of field and the this country. So going back to the fundamentals.
Ante, I have one question here.
Yeah.
Uh, Tableau has a feature that can easily recognize US coordinates, like whatever the. So if you're using for like any Asia specific countries, in that case, latitude, longitude, how we can,
Yeah, even
how we
Tableau,
do
Tableau recognizes worldwide geographical locations.
worldwide. Okay.
So some locations are specific to US
Mhm.
because that pattern is not followed in other countries. That's why that those are shown separately. The
Okay.
county or congressional districts are not followed in other countries. So that's why
Hmm.
only US that pattern is there. For other countries like India, so the states, cities, even pin codes data is recognized with lat long.
Okay.
Okay,
Okay. Thank you.
when districts are also recognized.
Mhm.
Okay, so based on different countries, so Tableau recognizes the geographical locations. Okay, so advanced mappings serves users who are interested in visualizing data values and where they are happening. So if you want to show the aspect of where where they are happening, so you can use the mapping technique. So this section helps the users who are interested in customizing their mapping experience or applying the spatial understanding to non-geographic data also. Okay, so if you want to customize your mapping experience or apply spatial analysis, spatial understanding to non-geographical data using custom geocoding also, you can use this particular section. Okay, so Tableau mapping is highly customizable, so you can customize this mapping feature. So we'll see how we can do that from the three components of Tableau map. So there are three components of Tableau map. We can customize this mapping. Okay, so what are those three components? Latitude, longitude, and background map. So the three components are latitude, longitude, and background map. So using these three components, we can customize this mapping. So we also have automatic geocoding or default functionality, which is automatic geocoding. So we don't have to do anything for customization. We just have to click on the geofield, and uh, Tableau applies automatic geocoding like this. Automatic geocoding to the details of the specific member. Here the details of the specific member are country or region. So that's why we are getting the region specific member. Okay, like this. So we can also use city, and you can get the details on that level also. Okay. Okay, so this is the detail on a city level. Okay, so on a city level we can plot the graphs as well. Okay, so um, these are the data points for each and every city globally. So this is automatic geocoding. So you have done nothing, so we have uh, uh, you have done the automatic geocoding on a details of a specific member. Here the specific member is the city, so the detail is the city here. Okay, so you can even edit the locations also. Okay, Tableau allows for end users to be hands-on in their mapping analysis. You can play around with the different levels also. So the simplicity in mapping design allows Tableau to be highly flexible, so adapting to most data and business environments, and providing a unique visual approach to data using this mapping technique. Okay, so we will see how how does Tableau perform automatic geocoding of data. So we'll see how Tableau performs this automatic geocoding of the data. So we'll first try to understand how Tableau performs its mapping at each level. So first, understanding how Tableau performs mapping at each level will allow us to understand what can be customized. So first we'll try to understand how Tableau performs mapping at each level. So that will help us to uh, customize with the view. Okay, um, we'll see what can be customized and how it can be customized later. So by the way, we can also see how we can leverage this in different varieties of spatial analysis also. Okay, so we'll first consider the Excel data. So first look at the Excel data in the view. So we have region, and it has members like international, east, west, central. Okay, and also continent, Australasia, North America, Asia, and are the members. In the state field, we have Central, Maryland, California, and so on. So in country, we have different countries. So city, we have different cities, and postal codes also different. So during the data connection process, so this is a data source that we will connect to data Tableau. So during the data connection process, Tableau reads the first few rows of the data. So the rows may be many. So say there are 1 million rows in the data source. So but first Tableau is the first few rows of the data like this. So these are the first few rows, right? So Tableau is the first few rows of the data, and field names. So it reads the data, first few rows of the data, and also the field names. So state, continent, region, country, region, city, these are all the field names, right? So it reads the field names and the first few rows of the data. So the entries or the members in the data first few rows are also read. Okay, so and identifies the appropriate data type by reading the first few rows of the data and also the field name. Tableau automatically identifies the appropriate data type. It identifies the appropriate data type, be it a numeric data type or a textual data type, by converting it to a dimension or a field or a geographical field. Okay, so it identifies data type during this first step. Okay, so geographical roles are assigned in a similar fashion. Okay, so by identifying the data type, geographical roles are also assigned. So um, where we first check then cross-reference with Tableau's own geocodes files to see if the members match and to generate appropriate lat longitude fields within our connection. So first it will check if it is the data type is the um, geographical role or not. Okay, um, then it assigns the lat long. First it will check if it is a geographical role or not. It will check like using the text like state, zip, or postal. Okay, using these field names, it will first check with the text of the field names and also the data. Okay, first few rows of the data. So it identifies if it is um, a geographical role or not with the associated geographical keywords. Keywords are like state, postal, zip, and such keywords. So using that, it will also auto generate the lat long with the Tableau's own geocode files. Using after checking and confirming that it's a geographical field, it will auto generate using or Tableau's own geocode files. Okay, and it will generate the appropriate lat long within our connection. Okay, so within our connection, so it will generate the automatic geocodes. Okay. Okay, so it is identifying the state as a geographical field like this. So country as a geographical field, city, postal code. So these have, while connecting to the data, so these are identified as a geographical field. In the backend, Tableau's own geocodes are generated for the appropriate lat longs. Okay, so in this view, Tableau identifies state. It identifies states, country, or region. It identifies city and a postal code as a geographical fields and generates the lat long. Okay, right. So um, this is how uh, we can understand how the Tableau identifies geographical field in the backend. So here, so we'll see how we can modify locations within Tableau. So incorrect data or data that does not match with the Tableau directly can be corrected. Okay, so if there is incorrect data or if there is any data which is not matching up with Tableau directly, uh, using these different geographical roles and descriptions. So if there is any data which is out of the scope of this defined codes, um, that can be modified, okay, in Tableau as well. So this allows the end user to fully use the geocoding capabilities with the tool. So regardless of the data's cleanliness, so we can even do that manually by cleaning the data. Okay, by for modifying the locations. So even if there is a slight spelling errors, you can avoid correcting them at the data source level. Okay, so for example, if there is a slight spelling error, so you can correct that at the data source level and simply proceed to the analysis rather than asking for the IT team or the database team to correct that, which will actually hold your analysis pattern by blocking your time. So rather than doing that, you can do that directly in Tableau. So it will allow the flexibility for the end user to do that. Okay, so we'll actually do an activity to modify locations. So the objective here is to define a known geographic location for a field when it isn't automatically defined. For example, uh, map the locations of distribution centers of each region based on the state where they are located. So we'll see with an example how we can do that. Okay, so we will map the distribution centers for each region. So we only have a region data. We don't have a distribution center data. So we'll map distribution center with region on the state where they are located. Okay, on the state where they are located, and we'll see how we can modify the locations. So first I will tell you the directions and then we'll go into the detailed steps. So in the we'll create a new worksheet, and then we'll connect to training Superstore data, um, and um, and we'll copy the region field and name it as a distribution centers. So we have region field here. So we'll duplicate this and then uh, name it as a distribution center. Then we'll assign a geographical role for state or province. Okay, so we can do that by right clicking on geographical role. So we can change it to state or province. Okay, by duplicating the distribution center. So and then we'll create a map of the distribution centers which will only find unknown locations. Okay, um, we'll see null values in the null indicator. So we'll click on choose edit locations and make the mapping. Like for west we'll map it as California, so for central we'll map it as Illinois, for international as New York, south as Georgia, and east as Pennsylvania. So we'll actually do those mappings in for distribution centers. And so we'll label the marks as distribution centers. So we'll change the mark type is to shape, and then we'll use a custom shape like a truck, and we'll see how we can do that. Okay, so we'll go into the detailed steps and actually try to do this what I've explained now. Okay, so I'm opening a new worksheet, and I already connected to the training superstore's sales.xls data source. So in the data window, um, I will right click on the region field and then select duplicate. So then right click on the copy and rename and select rename, and name the copy as distribution centers. These are the distribution centers. Okay, right. So in the data window, we'll right click on the distribution centers and choose geographical role and state. So we'll assign which as state or province. Okay, so as you can see, a geographical role has been assigned. So I'll go back. So earlier it is only a text field indicated by equal to ABC. Equal to indicates that it's a calculated field or a duplicate of another field. So region is a field which is a text field. Okay, so we are actually uh, right clicking on that, and then I'm redoing that. So we are assigning a geographical role to state. So it has been identified as a geographical field. By looking into the icon, you can identify that it's a geographical field. Now uh, from the data window, we'll drag distribution centers to detail. Okay, right, and then choose and then create a point map. So this is a point map, okay, or a symbol map. So we'll notice that null fields are existing, 5 unknown null fields. So um, we have noticed that there are null fields which are existing in the data. So at the bottom right, this is the null indicator. So we'll click on the null indicator. We'll click on the null indicator, and this will pop up a window like this. So we'll click on edit locations. Okay, for correcting the unknown locations. So there are 5 unknown locations here. We'll click on that. So this will create a window like this called edit locations. So we'll assign the um, states to represent the location of the distribution centers. Okay, so here for central, we'll assign a matching location. So these are the states. So for central, we'll give Illinois. For east, we will assign Pennsylvania. For international, we'll give either New York or New Jersey. We will give New York. So for south, we'll give Georgia. and for west we'll do California. Okay, so basically mapping the states to represent the location of the distribution center. Okay, so this is our data and this is the mapping data. Click on OK. So from the data window, we'll drag distribution centers to label on the marks card. So you might have noticed that that the map has changed from the globe to only United States because we are having only distribution center data for US here. Okay, so from the data window, we have to drag distribution centers to label on the marks card. Okay, so we have labeled the distribution centers as international for New York, Pennsylvania East, Georgia South, Central for Illinois, and California for West. Okay, right. Now, so we can also make a custom image. So for representing the distribution center, we'll use some image like a truck for representing a distribution center. Okay, so first what we have to do is to make a custom image available. So it should be taken from the repository, uh, from documents, my Tableau repository, um, shapes. So to make a custom image available in the repository, you have to create a new folder in the shapes directory. So this is the shapes directory in documents, my Tableau repository, and shapes. Okay, you have to create a folder called my images, and you have to copy the image called this trucks.png. So it is I'll be providing you, or you can download it from the net also. So you can use any image that you want for a truck. Okay, you have to first drag drop into this shapes my images folder. Okay, so you can retrieve from this location. Okay, right. So first we have to drop the image in that location. So on the marks card, so we'll change the mark type to shape. So from automatic, we'll change that to shape here and choose more shapes. So here we'll click on shape and choose more shapes here. Okay, and we'll click on reload shapes. Click on reload shapes. So we have to navigate to the shape palette for my images. So you have to navigate to the shape palette for my images. So my images is the folder that we have created. So in that we have this image. Okay, select that image of a truck and click on apply and OK. Okay, so from measures, we'll drag number of records to size on the marks card. So from measures, we'll drag the number of records to size on the marks card. Okay, so click on the size again to increase the size of the marks. So to increase the size of the truck, we can just increase the size like this. So this will show the size of the distribution center. Okay, this is how you can modify the locations by mapping the states to the data that you have, to the distribution centers. So this is how you can modify the data in the view also. So even if there is a data which is not available in Tableau, or which is not recognizable to Tableau, we can map the data as well, by performing edit locations or modifying the locations like this, and then you can plot the data like this. Okay, right. So we have few more maps that we will discuss tomorrow. So called dual axis map or combination maps, or we'll discuss different types of maps like background maps also. We'll see map box, and also different background images, using mapping techniques. Okay, so we'll see how we can use geocoding addresses with data blending also, or to create path mapping to point distribution, or for doing the spatial analysis, we'll see how you can use background images. So we'll see how you can use background images for spatial analysis. So there are different mapping techniques that we use in real-time scenarios. So we'll see that in tomorrow's class. Okay, so see you tomorrow.
Okay, thank you, Kranti.
Thank you,
Thank you.
Kranti.
Thank you. Thanks for your time. Bye.